Okay, number 12, we're dealing with a square root function here. So first thing we need to do is, again, finding your starting point is the same as finding your vertex for an absolute value function. Okay, so where would our starting point be? Say it again, please. 0, 4. It's the exact same as finding the vertex of an absolute value. Okay, well what this tells us then is that our shift, since the x-coordinate is 0, we don't shift left and right. We stay at 0. But our y-coordinate is 4. That's a positive 4. That means we move up 4 in the y direction. Okay? So next, when we go and plot points, we want to plot points for the equation without the shift. So very literally, take your thumb or take your finger and cover up the shift. Everything that's showing is what you're going to be plugging the numbers into. So we got to plot points for y equals negative 4 times the square root of x. Well, we use our friendly numbers for x. 0, 1, 4, 9. And we can plug those in. So the square root of 0 is 0. 0 times negative 4 is 0. The square root of 1 is 1. 1 times negative 4 is negative 4. Square root of 4 is 2. 2 times negative 4, negative 8. The square root of 9 is 3. 3 times negative 4, negative 12. All right, well, we want to plot those points. So we have 0, 0, 1, negative 4, 4, negative 8, and then 9, negative 12 is way off our graph, so we don't need to worry about it. But what we can do now is shift each one of those points up 4. So our graph is going to go through these guys. Going to look something like that. Any questions on 12? Okay, looking at number 13 here, we have an absolute value function. So, I even have it written up on the board. There are different formulas that we've talked about so far in Unit 2. So, for the absolute value function, how do we find our vertex? Vertex is HK. So, what is our vertex here? Say it again, please. 1, 0. Because remember, x is hexed, right? X is hexed. It says negative 1, so we want positive 1. Okay, so we go to our vertex of 1, 0. Now, there's an axis of symmetry that runs vertically through your absolute value functions. And the axis of symmetry is really easy to find. It's just the equation x equals then whatever your x-coordinate is of your vertex. So this is the axis of symmetry. Whatever's on the right side of that is the same as on the left side of that. Okay, well, the next piece is we want to find out what our value of A is. Because what does A give us?
Rise and run.
Rise and run of which side?
The right.
The right side only. So A in this equation is what? 1, which gives us a slope of 1 over 1. So we count up 1, right 1. Up 1, right 1. We can keep going. Each one of those points needs to be mirrored to the other side. And then we just graph this with some nice straight lines on either side. And there we go. We're done. Any questions on 13? All right, looking at number 16. So for number 16, again, we're graphing an absolute value, so we got to find our vertex, which is located where? 1, 0. X is hexed, Y is Y's. There is no 0 out here, or there is no number out there, so it's 0. Okay, so our vertex is at 1, 0. Our axis of symmetry is x equals 1. And our value of A, which is the slope of the right side, is -1. Which means we're counting a slope of -1/1. So, let's first go to our vertex at 1, 0. Just like the last problem then, our axis of symmetry runs vertically through that point. That's the equation x equals 1. On the right side of our graph, we count a slope of -1, which is down 1, right 1. Okay, we make sure to mirror those points to the other side. And there's our graph. Any questions on 16? So our Unit 2 Formative 1 review. First off, the sections that's covered here are all the sections we've done in Unit 2 so far. So, just to make sure you know what you're supposed to be studying here, we are on sections 2.3, 2.4, 2.7, 2.8, and 6.8. Those are the sections that are covered on tomorrow's quiz. All right, it's the first 5 sections we've covered so far in our Unit 2 packet of notes. So what I want to do today is I want to try to get the biggest bang for our buck, meaning I want to make sure to work problems that have multiple pieces so that we can practice multiple things in the same problem. So I want to start with number 5. Let's go down to number 5 here. For number 5, we want to write the equation of the line containing the points 3, 1, and 6, -1. So, first off, we need to find slope for this line. So to find the slope of the line, we need to use the slope formula. Well, it's up on the board. What is the slope formula? Right. We've got to take slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I told you guys before, just as a nice little way of organizing your work, making sure you're plugging in correct, above these points, go ahead and write x1, y1, x2, y2, because now all you're doing is plugging into that. So we have -1 minus 1 over 6 minus 3, which gives us a slope of what? -2/3. Good. So that's our slope. Well, to write the equation of a line, we still need to know a point on our line. It's really nice and easy if we know the y-intercept, because that would allow us then to write slope-intercept form right away. But in this case, neither of these points are the y-intercept. So we get to pick a point. Which point would you like to pick? 3, 1. Okay. So we're going to pick 3, 1 as the point that we know. And using that information, that point and that slope, we got to write the equation of our line. There are 2 ways of doing this. Both are correct. You get to pick whichever way you feel most comfortable working. The first one is using point slope. Point slope is y minus y sub 1 equals m times x minus x sub 1. So we take our point, and our point gives us the x1 and the y1 for that equation. And we take our slope, which gives us the m for that equation. So we have y minus 1 equals -2/3 times x minus 3. We have to distribute the negative 2/3, which gives us negative 2/3 x. And now what's negative 2/3 times negative 3? A what? Say it again. Positive 2. Negative times a negative gives us a positive. So now we need to add 1 to both sides. So y equals negative 2/3 x plus 3. Any questions on working that problem using point slope? All right, well, the other way of solving this would be to use slope-intercept form. Slope-intercept form is y equals mx plus b. Well, again, the point that we are given gives us an x and a y. And the slope obviously gives us our m. The only thing we don't know in that equation is the b. So we have to solve for b. So we have 1 equals negative 2/3 times 3 plus b. Well, negative 2/3 times 3, the 3's cancel, gives us just negative 2. So 1 equals negative 2 plus b. Add 2 to both sides. 3 equals b. So we now know our y-intercept is 3. We know our slope is negative 2/3. We can write the equation of our line in slope-intercept form. Y equals negative 2/3 x plus 3. It does not matter which way you solve this, point slope or slope intercept. It gets you the same answer. You work whichever way you feel most comfortable. Okay? Questions? Let's take a look at number 6. In number 6, they want us to write the equation of a line that is perpendicular to y equals 2/3 x plus 2 and passes through the point 2, 1. So the key here is that we need to know information about perpendicular and parallel lines. So what do we know about the slope of parallel lines? What do parallel lines look like? Train tracks. Do they have the same slope or a different slope? Same slope. Parallel lines have the same slope. How about perpendicular lines? Okay, it's not just opposite, it's opposite reciprocal. One's positive, one's negative, and you have to flip the fraction. So, remember, when we were working these types of problems, I gave you just a little hint to organize your work. I write our line off to the side, and I write down the information I know about our line. I know it's going to pass through the point 2, 1, and our slope, I've got to find it. Our slope is going to be perpendicular to this line, which has a slope of 2/3. There we go. We have to take the opposite reciprocal of 2/3. So our slope is negative 3/2. Okay, so now using the information about our line there, that point, that slope, you need to write the equation of the line. You can use point slope or you can use slope-intercept form. It's exactly like we did in number 5. Please take a moment now to write the equation of this line. So if we work this by point slope, and again, you could use slope-intercept form if you want to, but point slope is y minus y sub 1 equals m times x minus x sub 1, and we use our slope and our point that they give us. So y minus 1 equals negative 3/2 times x minus 2. We need to distribute the negative 3/2. So y minus 1 equals negative 3 halves x. Negative 3 halves times negative 2 gives us a positive 3. And now we need to add 1 to both sides. So our final answer should be y equals negative 3 halves x plus 4. Any questions on number 6? Now what we want to do on these problems here is we want to write the equation of these functions that they give us in the graph. Okay, so let's start out with number 7. We need to decide first what type of function we're graphing here, or they gave us the graph of. Is this a line? Is this an absolute value? Or is this a square root? Absolute value. Remember, value starts with a V. The graph is a V, so this is an absolute value function. So the first thing we need to do then, after we decide which function we're dealing with, is write down the general form for an absolute value function. It's written up on the board there already. Y equals A times the absolute value of x minus h plus k. Well, what do h and k give us? Vertex is what we call it for an absolute value. And what is the coordinates of our vertex? Negative 2, comma, negative 3. So that gives us h and k already. Well, next we've got to find a. What does a give us in the graph? Slope of the right side of our graph only. So the slope of the right side of our graph is up 1, right 1. And so therefore, yes, a is just 1. That's all the information we need. We just plug that into the general form. Y equals 1 times the absolute value of x minus negative 2 plus a negative 3. And just simplify it down. So we have the absolute value of x plus 2 minus 3. Any questions? Let's take a look at number 11. Now for number 11, we need to decide what type of function we're dealing with. It's going to be what? Well, you're telling me it's going to be an inequality, which I agree with that because it's shaded. Only inequalities are shaded. Okay? But we need to decide what we're dealing with. Are we dealing with a line? Are we dealing with an absolute value? Or are we dealing with the square root? We're dealing with an absolute value because our border is a V. So we write down our general form for an absolute value. Y equals A, absolute value of x minus h, plus k. And we need to work this just like we did that last problem, that number 7. So, where's our vertex? Sitting right there at, 3, negative 2. And A is the slope of the right side, which in this case is up 1, right 1. So, going up 1, right 1, we get a slope of 1. So, to write the equation of this, we say y equals 1 times the absolute value of x minus 3 plus a negative 2. So that's y equals the absolute value of x minus 3 minus 2. Okay, the issue here is that this is not really an equality. We don't know what that symbol is supposed to be there yet, but it's not supposed to be an equal sign. So we've got to decide if it's less than, greater than, less than or equal to, greater than or equal to. Okay, you're telling me it's not going to be the equal to ones. Why? Because it's a dashed line. So now we got to decide, is it going to be less than or greater than? So the way we do that is you want to pick a test point that is on the true side. You can pick any test point you want, but it's going to be easier for you, it's going to be more straightforward if you pick one that's on the true side.
1, 2, 0.
We could pick, well, we can't pick 1, 0 because that's on our boundary. You could pick 1, 4, clear up there. You could pick 1, 1, sitting right there. Anything that's in the shaded region will work. Smaller numbers are best, so let's go ahead and pick 1, 1. Okay, so we're going to test 1, 1. We plug into our inequality we have written here. So 1 is something to the absolute value of 1 minus 3 minus 2. Well, what's 1 minus 3? Negative 2. So what's the absolute value of negative 2? 2. So 1, and we have 2 minus 2, which is 0. So that side becomes 0. And is 1 greater than or less than 0? 1 is greater than 0. And since we picked a true test point, that is the inequality we want to use. So our equation, our inequality, is going to be y is greater than the absolute value of x minus 3 minus 2. Any questions on number 11? So then let's try another example. Let's go, oops, didn't mean to write on that. Let's go down to, say, number 15. Okay. Number 15. What type of function are we working with here? Square root function. So we've got to write down our general form for a square root function. Y equals a square root of x minus h plus k. Well, h and k are given to us by the starting point. Okay? We need to go through and find where that is, where the starting point. What's our coordinates of our starting point? Starting point is 0 what? 0, 3. There's our h and our k. We also need to find a. Now, a can be found by picking another point on your graph and plugging that other point in for x and y. So you plug in for x and y, you plug in for h and k, and then you solve for a. Okay? That's the way you would do it. I'm going to give you guys a wonderful hint. We only need to deal with a being 1. You're welcome. So, looking at this, see the next point on our graph? It's at 1, 1. Or at least 1, 1 away from our starting point. So that indicates that a is going to be 1. Okay? A would be something else if maybe we had to go up 2 and over 1 to get to that next point, or down 3 over 1 to get to that next point. But all we're dealing with today and tomorrow is when a is 1. Okay? So we have this. So plug in. Y equals 1 times the square root of x minus 0 plus 3. And simplify it down. So we have the square root of x plus 3. Please remember that square root stops after the x. Okay, that plus 3 is on the outside of the radical. And that's our solution. Okay, folks, we have roughly 10 minutes left in class. I would like to work a few more of these for you. We have more on this page, which are writing functions. We have more on the next 2 pages, which are graphing functions. You get a pick. I'll work whatever you want right now. Yes, ma'am. Sure. Number 8, we want to know what is the equation of this graph. Well, again, what type of function do we have? Absolute value. So we need to write that equation. Y equals a times the absolute value of x minus h plus k. Where's our vertex? Sitting right there at 5, 1. Okay. What is the slope of the right side of our graph? So you're going down 2, right 1. So down 2, right 1 gives you a slope of -2. Okay. So we want to go ahead and plug that in. We have y equals -2 times the absolute value of x minus 5 plus 1. Well, is there any simplification we can do to that one? Like any double negatives or anything like that? No. So that's it. Okay, looking at number 10, what kind of function do we have? We only have 3 options, folks. Is it a line, is it an absolute value, or is it a square root? It's going to be a line. So y equals mx plus b. So now that we have our basic formula written down, we've got to find b, which is where it crosses the y-axis. Where is that? There we go, -1, right down here. So b equals -1. We got to find m, which is our slope. So we got to look for another point on our line that's easy to find, which to me looks like right about there. That has a rise of 3, a run of 1. So that's a slope of 3. So we have y equals 3x minus 1. But remember, it's not y equals. We really don't know what inequality goes there. But is it going to be less than, greater than, less than or equal to, greater than or equal to? Which two are we trying to decide between? I think I heard you guys say this. Okay? It can't be the or equal to ones, right? Why? Because it's a dashed line. So it can't be these guys because it's a dashed line. So to decide which one it's going to be, less than or greater than, we use our test point. They gave us a test point of 0, 0. Is that on the true side or the false side? That's on the true side. Always use a point on the true side. It's simpler that way. Okay? So plugging in our test point of 0, 0, we have 0 is something to 3 times 0 minus 1. 3 times 0 is 0, and 0 minus 1 is -1. So is 0 greater than or less than -1? Greater than. So that means we want to use a greater than symbol because we want this to be true. So our answer is y is greater than 3x minus 1. Any questions on 10? Number 16, what type of function do we have? Square root function. So the general form is y equals a square root of x minus h plus k. Well, h and k give us the starting point. The starting point is at -3, 0. So our starting point, -3, 0. Remember I told you guys for square root functions, what's our a going to be? A is 1. You can verify that because to the next point on your graph, you have to go up 1, right 1. So a is going to be 1. Okay? Well, plug into our general form there. Y equals 1 times the square root of x minus -3 plus 0. And simplify it down. So y equals the square root of x plus 3. We don't need to write plus 0 at the end. And there we go. Number 18. For number 18, we have an absolute value. Okay. Also notice that we have an inequality, not an equation. So therefore, we're going to do what to this guy? We're going to shade it. So we need to find our vertex first for our absolute value. Where's that located?
-4,
-4, -3. Please remember x is hexed. So what's in there with the x, it's opposite that. Okay? So we're at -4, -3. What is the slope of the right side?
1.
Okay, so going through here, we go to our point -4, -3, which is right there. We have an axis of symmetry, which runs vertically through that. And that axis of symmetry has the equation just... So our axis of symmetry is just x equals -4. Remember, it's just x equals, then your x coordinate of your vertex. So that's really easy to find. On the right side of that, our slope is 1. So up 1, right 1. Every single one of those points needs to be mirrored to the other side. Okay, so now we need to decide, are we graphing this with a solid line or a dashed line? Right, this is just greater than, so that means we go with a dashed line. All right, so please make sure that you graph this clear across the entire graph. Okay, so there's our absolute value. There's our boundary. We now need to decide where we're going to shade this. So we want to pick a test point. Okay, 0, 0. Is that on the inside of the V or outside the V? 0, 0 is outside the V. So if you're testing 0, 0, we want to plug that into our original. So 0 is greater than the absolute value of 0 plus 4 minus 3. 0 plus 4 is 4. What's the absolute value of 4? So we have 4 minus 3, which gives us what? 1. So is that true or false? That is false. So remember then, this out here must be the false side. This inside is the true side. Always shade the true side. So we have to shade everything that's inside the V. Any questions on 18?